Our solar system, the place we call home, lies about 26,000 light-years from the center of our galaxy, the Milky Way. Or around 2/3 the way out. The story of how these huge planets came to be orbiting an average yellow star is 6 billion years long. And since we don't have that much time, I'll speed it up a bit. It starts with a bang. Long ago, an ancient star exploded, littering space with swirling clouds of the materials it had made while it lived and the heavier metals it created as it died. We know this because we can see similar fields of dust out in space today. They are called nebulae, and they are very beautiful. Every nebula is different, and in our case, the clouds contained nitrogen and oxygen and iron and silica and all the other stuff needed to build a world like ours. Then the tireless force of gravity started to pull it all back together, and the heavy engineering that produces planets began. Vast spirals of dust began to form. And at the center of one of these, a rocky planet called Earth started to take shape. Built of stardust and assembled by gravity. Fast forward 100 million years, and it had grown into a giant ball, sweeping up billions of tons of celestial debris. This is where the Earth came from, and therefore how you and I began. But our planet would have remained a large, sterile ball of rock and metals and minerals forever, were it not for one more event, one more expression of the forces of nature. 93 million miles away, at the heart of the giant nebula, the pressure and temperature of a ball of hydrogen gas had become so great that the atoms were beginning to fuse. A new star, our sun, was coming to life. As the sun ignited, it gave off a huge blast of solar wind, a radioactive gust of energy. This blew all the remaining dust and gas that was left over from the nebula out to the edge of the solar system, which is why everything is nice and orderly today. In the outer reaches of the solar system, we have the huge gas planets, Jupiter, Saturn, Uranus, and Neptune. Further in are the denser, rockier planets, Mercury, Venus, Mars, and of course, the Earth. Lucky for us, the Sun is 865,000 miles in diameter, or just the right size to burn consistently for a very long time. 8 billion years. Long enough to allow the next development to take place. Life.
These tiny mineral grains are the seeds of a new rocky planet. Over time, they start to stick together.
You'd have one dust molecule and another dust molecule, and they would basically slam into each other and become one slightly bigger dust molecule. And they would pick up more and more and more. This process is called accretion. As these things got bigger, they became basically rocks.
Then, rocks slam into other rocks and form boulders. Boulders smash together to form bigger boulders.
Eventually, you got something big enough that its gravity was strong enough that it could start drawing material in. So instead of just slamming into material and gaining mass that way, it was actually actively pulling material in.
In our own solar system, there were many growing infant planets at first, maybe 100. Most of them didn't make it.
If you go to the asteroid belt and look at the asteroid 4 Vesta, that is a good indicator of how big a rocky planet has to be before it can pull itself into a spherical shape.
Vesta is only 329 miles across. Not quite big enough to become a sphere. For a growing planet to become round, it has to reach 500 miles across. Then it has enough gravity to crush it into a sphere. Any smaller, and it stays an irregular shape. As round infant planets keep eating up stuff, each collision makes them hotter and hotter until they start to melt. Now, gravity begins to separate the heavy stuff from the light.
Lighter materials tend to float up into a crusty film, and the heavier materials, many of the metals, falling down and forming a much denser core at the center of the planet.
The young planets are finally beginning to look like planets. But now, they have to survive a period of violence and destruction. A brutal phase that determines which planets will live and which planets will die.